Alright, we're going to talk about conditional statements. A conditional statement is a statement written in an if-then format. So an example of a conditional statement might be, if we win the game, then we will go to the playoffs. So that's an if-then format. If this happens, then this will happen. If we win the game, then we will go to the playoffs. And you'll see the conditional statement written in letters and symbols like this. So if you see this, this is if P, then Q. So in the scenario that I just came up with, P would be we win the game. If P, then Q. Q would be we will go to the playoffs. Okay, the hypothesis is the phrase following, but not including the word if. So remember, this was if P, then Q. So all of this was the P. The hypothesis is the P in the situation. So in this example, the hypothesis is we win the game. The hypothesis is we win the game. And then the conclusion is the phrase following, but not including the word then. So everything that came after the word then was we will go to the playoffs. That is the Q. Then Q. So the conclusion is Q. And in this example, the conclusion was we will go to the playoffs. Alright, example 1 says, state the hypothesis and conclusion of the conditional statement below. If you have a B average and no more than 2 absences, then you can exempt your final. Remember, the hypothesis comes after the word if. So right here, you have a B average and no more than 2 absences. That is the P. That is the hypothesis. Then you can exempt your final. Remember, the conclusion is everything that comes after that word then. So then you can exempt your final. You can exempt your final would be the Q, or the conclusion. So let's write that out. The hypothesis is you have a B average and no more than 2 absences. And the conclusion is you can exempt your final. Okay, let's look at example 2. It says, rewrite the statement below as a conditional statement and then state the hypothesis and conclusion. Notice this statement is not in an if-then format, and a conditional statement should be in that if-then format. So let's read what we have here. It says, a car with poor brakes is a menace on the highway. A car with poor brakes is a menace on the highway. So how could we rewrite that as an if-then statement? If I want to rewrite that, I would say if a car has poor brakes, then it is a menace on the highway. So we're given the same statement, the same information, we just change the format and make sure it's in that if-then format. And once we have it in an if-then format, then it's real easy to see what the hypothesis and conclusion is. Remember, the hypothesis is everything after the if. So the hypothesis is a car has poor brakes. And then the conclusion is everything that comes after the then. So the conclusion is it is a menace on the highway. Alright, example 3. Same directions. We want to rewrite the statement below as a conditional statement and state the hypothesis and conclusion. All right, the statement says Mrs. Ellison gives her students homework on days that end in Y. Mrs. Ellison gives her students homework on days that end in Y. Now, because of the order of the statement, a lot of kids want to say, if Miss Ellison gives her students homework, then the day ends in Y. But think about those two things. The day ending in Y isn't going to be determined by whether or not she gives homework. It's the other way around. If she's given homework on days that end in Y, the days end in Y on their own. That comes first. And then if she gives homework, it happens to be on the day that ends in Y. But this should be the if part of the statement. This should be the then part of the statement. So the conditional should read like this. If the day ends in Y, then Mrs. Ellison gives her students homework. If the day ends in Y, then Mrs. Ellison gives her students homework. And again, once you have the conditional written out, hypothesis and conclusion should be pretty easy to identify. The hypothesis comes after the if, so the day ends in Y. And the conclusion comes after then. Mrs. Ellison gives her students homework. Alright, a converse statement is formed by switching the hypothesis and conclusion of a conditional. So remember, the original conditional statement is if P, then Q. So if we switch those, switch the hypothesis and conclusion, then our statement is if Q, then P. We're switching that P and Q. We're switching the hypothesis and conclusion. So now if I go back to my original conditional statement, my original example was if we win the game, then we will go to the playoffs. So if I switch the hypothesis and conclusion, the converse is if we go to the playoffs, then we won the game. All right, let's try this on example 4. It says state the converse of the conditional statement. And the statement is if a car has poor brakes, then it is a menace on the highway. We used this one earlier. So we're going to switch the P and Q. So the converse is if a car is a menace on the highway, then it has poor brakes. That would be the converse of that conditional statement. All right, example 5. Write the converse of the conditional statement below and tell whether it is true or false. So the conditional is if an angle has a measure of 120 degrees, then it is an obtuse angle. So for the converse, we switch the P and Q. We switch the hypothesis and conclusion. So the converse would be if an angle is obtuse, then it has a measure of 120 degrees. All right, so let's evaluate that statement. If an angle is obtuse, then it has a measure of 120 degrees. Do all obtuse angles have a measure of 120 degrees? No, so that is a false statement. And before I explain that further, let's read this next definition. A counterexample is an example that follows the hypothesis but not the conclusion. Okay, so in other words, a counterexample would be something that is obtuse but not 120 degrees. It has to fit the hypothesis, but not fit the conclusion. Okay? And another way you can talk about a counterexample is that it is an example that proves a statement is false. An example is something that supports something. A counterexample disproves it or proves it to be wrong. So in this case, what's an example of an obtuse angle that's not 120 degrees? That would be a good counterexample for that converse statement in example 5. So you could say 100 degrees. You could say 150 degrees, 170 degrees. Anything that is an obtuse angle that is not 120 degrees would be a good counterexample to that statement. All right, a negation is the denial of a statement. It basically adding the word not into your statement. And you'll see this with this symbol right here in the statements. Okay? An inverse is formed by negating both the hypothesis and the conclusion of a conditional statement. So original conditional statement is if P then Q. So inverse, we're negating both of them. So we're going to say if not P, then not Q. So if I go back to my original example, my original conditional statement was if we win the game, then we will go to the playoffs. So the inverse of that statement would be if we do not win the game, then we do not go to the playoffs. So it's basically the exact same as the original statement, but with the word not added into both the hypothesis and the conclusion. We've added those negations in. All right, write the inverse of the conditional statement below. If you pass the STAR test, then you will graduate. So we want to write the inverse. So we're just basically adding the negations or the nots to both halves. So if you do not pass the STAR test, then you will not graduate. And there's the inverse. We've added the negation to both parts of the conditional statement. That's the inverse. Okay, example 8. Write the inverse of the following statement. Determine if the inverse is true or false. If false, give a counterexample. Okay, so the original statement here is if school is in session, then it is a weekday. So the inverse would be if school is not in session, then it is not a weekday. Oops. Not a weekday. Alright, so now we want to evaluate our inverse. If school is not in session, then it is not a weekday. Is that a true or false statement? That is a false statement. Now, if we're going to make the claim that it's false, better have some evidence to support that. We need a counterexample. We need an example of a situation where it's not a school day. It's not a school day. School is not in session, but that it is a weekday. We gotta stick with the hypothesis, but be opposed to the conclusion there. So we need an example when school is not in session, but it is a weekday. And you can come up with a lot of different examples. One possible example is Thanksgiving. And I cannot write today. Thanksgiving. Thanksgiving always comes on a Thursday. That's a weekday. But we also don't have school on Thanksgiving. So Thanksgiving is a day when school is not in session, but it is a weekday. So that is a counterexample to this statement. It proves that that statement is false. All right, and one more type of adjustment to the conditionals is the contrapositive. Contrapositive is formed by switching and negating both the hypothesis and the conclusion of a conditional. So remember that the converse, we switched the P and Q, switched the hypothesis and conclusion. Remember, for the inverse, we added negations to both of them. The contrapositive is kind of like a combination of those two things. Not only are we going to switch P and Q, but we're going to put negations on both of them. So where the original statement was if P then Q, the contrapositive is if not Q, then not P. And going off my original example, my original conditional statement was if we win the game, then we will go to the playoffs. The contrapositive to that would be if we do not go to the playoffs, then we did not win the game. There's the contrapositive. P and Q have been switched, and we added negations to both of them. If we do not go to the playoffs, then we did not win the game. All right, example 9 says write both the converse and the contrapositive of the conditional statement below. So here's the statement. If you run a red light, then you are breaking a traffic law. Remember, the converse switches the hypothesis and conclusion. So the converse would be if you are breaking a traffic law, then you are running a red light. All right, the contrapositive, after we've already switched P and Q to get to the converse, so now to make it the contrapositive, we just need to add the negations to the two sides. So, if you are not breaking a traffic law, then you are not running a red light. So this would be our contrapositive. Notice from the original conditional statement, P and Q have been switched, and we've added the negations into both parts of that statement. If you are not breaking a traffic law, then you are not running a red light. All right, example 10. Write a conditional statement for the statement below, then write its converse, inverse, and contrapositive. So the original statement is the road is slippery when it rains. Now that is not in an if-then format yet, so we need to first write it in an if-then format to make it a conditional statement. The road is slippery when it rains. So that tells me that if it rains, then the road is slippery. Same statement, same information, just in a different format. We got it in that if-then format, so it makes it a conditional statement. Okay, so for the converse, we switch P and Q. We switch the hypothesis and conclusion. So that would be if the road is slippery, then it rained. Okay, the inverse is when you keep the P and Q in the original order, but you just add the negations to both sides. So the inverse would be if it does not rain, then the road is not slippery. And then the contrapositive, we switch the hypothesis and conclusion, and we add the negations. So that would be, if the road is not slippery, then it did not rain. If the road is not slippery, then it did not rain. All right, we got one more thing we got to go over, and that is biconditional statements. Okay, a biconditional statement is a statement that is formed by combining a conditional statement and its converse. And you will see biconditional statements written this way. And you'll notice those arrows are facing both directions now instead of just one direction. What this means when you see this, it means if P then Q and if Q then P. It means the original conditional statement and its converse are both true at the same time. Rather than writing all this out, we can write it like this, which is a little bit shorter. Okay? Now, a biconditional statement has some key words in it that you will always see. It's got the words if and only if. Now, if I'm going off of my original conditional statement, if we win the game, then we will go to the playoffs. Here would be a biconditional statement for that situation. We will go to the playoffs if and only if we win the game. Notice those words, if and only if. You will see those words in every single biconditional, if and only if. We will go to the playoffs if and only if we win the game. That is a biconditional statement. All right, let's look at example 11. Write the conditional statement and its converse within each biconditional. So we're going to take a biconditional statement and break it down into the two separate statements that it means are true at the same time. So it says two angles are congruent if and only if their measures are equal. So you see those magic words that let you know that that's a biconditional statement. So the P and the Q are two angles are congruent and their measures are equal. So I need if P then Q to be true, and I need if Q then P to be true. So this one statement means these two things at the exact same time. If two angles are congruent, then their measures are equal. And it also means if two angles measures are equal, then they are congruent. So you can see how writing a biconditional statement saves yourself a little time. This one statement is saying all of this right here. Both the conditional statement and its converse are both true at the same time in a biconditional statement. All right, write each definition as a biconditional. So it says a triangle is a three-sided polygon. So I want to write that as a biconditional statement. A polygon is a triangle if and only if. Anytime you're writing a biconditional statement, you got to see these words, if and only if. It has three sides. A polygon is a triangle if and only if it has three sides. All right, example 13. Determine if each biconditional is true. A square has a side length of 5 if and only if it has an area of 25. So if I'm testing the truth of this statement, I have to check both the conditional and its converse for being true. So let me think about this here. A square has a side length of 5 if and only if it has an area of 25. So let's try it this way. If the side length of a square is 5, does that make the area 25? Well, yeah, if you got a square, remember you can find area of a square. You can either do side squared or you can do length times width because it's a type of rectangle. But 5 times 5 would be 25. So if a side length is 5, it does have to have an area of 25. So it's true in that direction. Let me try the converse. If a square has an area of 25, then it has a side length of 5. Well, a square, all 4 sides have to be congruent. So if I know the area is 25, I can always just take the square root of that to find the length of the sides. And if I take the square root of 25, I'm going to get 5 every time. This statement works in both directions. So this is a true biconditional statement. Let's check B. A figure is a quadrilateral if and only if it is a polygon. Okay? A figure is a quadrilateral if and only if it is a polygon. Okay, if it's a quadrilateral, then it is a polygon. Well, that's true. A quadrilateral is a type of polygon. So all quadrilaterals are polygons. Let's see if it works the other direction. If it is a polygon, then it is a quadrilateral. Well, that's not necessarily true. Polygons can have all different number of sides. Quadrilateral means it has 4 sides. Well, a polygon could have 5 and be a pentagon, or 6 and be a hexagon, and so forth. So while this statement works in one direction, it doesn't work in the other direction. And for it to be a biconditional that's true, it's got to work both ways. And this one does not. So this biconditional is false. Alright, right down here at the bottom of your page, you have a quick summary and like a little one-stop shop to remind yourself what each one of these things that we discussed is. So you can refer back to that and see all that information a little quicker when you're doing your homework. But that was your lesson on conditional statements.